Welcome. In this session, we will do our final example of evaluating a definite integral using the fundamental theorem. In this problem, I have two terms in the integrand, which I will need to do using different substitutions. In such examples, it's better to do it using the approach we have been using. First, calculate an antiderivative in terms of x, then you find the net change. Even if you know or somebody shows you how to change limits in a definite integral, it's not a good idea to do that in problems where you have to use different substitutions for different terms. Let's look at each of the terms individually. The first term is x over square root of x squared plus 1, or x times x squared plus 1 to the power negative 1/2. So I would use for my substitution u equals x squared plus 1. Du is 2x dx. I have x dx, so this will work. X dx is du over 2. Now I have to rewrite this integrand 1 over square root of x squared plus 1 in a form to which power rule will apply. Change x squared plus 1 to u square root to the power 1/2. Bring it to the numerator, making it u to the power negative 1/2. Apply the power rule. Negative 1/2 plus 1 is 1/2. So the antiderivative will be the constant factor 1/2 times u to the power 1/2 over the new exponent, which is 1/2. 2 times 1/2 is 1. And if I go back to the original variable x, I will get x squared plus 1 quantity to the power 1/2, or the square if you want to do the arithmetic at the end. To find an antiderivative for the second term, x cubed over x power 4 plus 1, I am going to set the new variable to be x power 4 plus 1. To avoid confusion with the previous substitution, I will call this substitution w. So let's set w equals x power 4 plus 1. dw is 4x cubed dx. I have x cubed dx in the integral, so this will work. X cubed dx is dw over 4. The denominator x power 4 plus 1 is w. So I have 1/4 dw over w, or 1/4 1 over w dw. And antiderivative for 1 over w is ln of absolute value of w. So this indefinite integral will be 1/4 times ln of absolute value of w. Should really have used different names for these constants. Since I'm going to ignore them, it doesn't matter what you call them. And now again I have to go back to the original variable x. W is x power 4 plus 1. Let's plug that in. So an antiderivative for the original function will be this plus this. To calculate the definite integral, I have to find the net change in this. For the first term, an antiderivative is square root of x squared plus 1. For the second term, ln of x power 4 plus 1 over 4. Then you plug in 2 and negative 1 for x and then subtract. So plug in 2 for x, plug in negative 1 for x. 2 squared plus 1 is 5. 2 power 4 plus 1 is 17. Negative 1 quantity squared plus 1 is 2. This is also 2. Should also distribute the negative, which gives me the final answer. This concludes our illustrative examples for using the fundamental theorem to calculate definite integrals.